explain this now. This section shows high potential for a structural trap. See how the salt dome interacts here.
Yes.
Look at this structure right here. The amplitude anomaly is strong.
Yes, the seismic attributes confirm a potential reservoir trap at 2,000 meters.
Reflection data reveals the deep petroleum structures that may contain crude oil.
This bright spot indicates hydrocarbons trapped in the anticline structure.
I agree. The AVO analysis supports a strong potential discovery here.
As you can see, the porosity peaks here at the high angle lamination.
And the Klinkenberg correction confirms the tight gas trend.
The pressure gradients look promising here.
Yes, and the API gravity confirms the light sweet crude. This one is definitely number one.
The preliminary readings are inconsistent. We need another sample from this quadrant.
High salinity confirmed in this core. I've logged the data.
Good, let's move on.
Confirmed. That's the spot. Let's mark it and move to the next waypoint.
Access roads are designed to support heavy crude oil drilling and petroleum logistics equipment.
So if we route the main supply line through here, we minimize the impact on the access road.
That works, but watch the pressure drop at the wellhead.
The soil samples show high sensitivity here.
And the drone confirms the nesting site nearby. We must report this immediately.
The exploration rights are secured.
Keep that pressure steady on the drill. We're almost there.
The overheads on the Caspian field are still too high.
But the revised tax structure changes the Q3 outlook significantly. We are looking at a 20% upside.
As you can see, the reports confirm a commercially viable reservoir.
Excellent work. This is a significant discovery.
These are the proposed drilling paths based on the seismic data.
And the projected output for the new wells looks promising.
Check the specs. We need this perfectly level for the rig placement. Understood, boss. We're almost there.
Bring it down slowly. Watch the clearance on the left. Easy now. Set it down right there.
Inspection is complete. All clear. Prepare for the lift.
Keep it steady on the east side.
Copy that. Almost locked in.
This is hard shale.
We need the roller cone.
Agreed. It matches the expected strata above the reservoir.
torque it up. We're clear on the connection. Keep it moving.
We have a significant spike on the chromatograph.
Confirmed. Check the cuttings at the last interval.
Formation tests confirm that the reservoir can produce crude oil at commercial rates.
Guide the pin.
Got it. Stab it now.
Tongs, engage the connection.
The packer isolates the reservoir, sealing the annulus. This ensures efficient pressure management and diverts the flow directly into the tubing.
The GOR is stabilizing after the adjustment. Good. The pressure response looks consistent with the model.
The pressure is too low. We're not getting enough natural flow.
We'll switch to the ESP system as planned. The simulation shows increased recovery.
We did it! Look at that flow!
Textbook extraction.
The flow rates look perfect. Pressure is stable.
Well done, team. We are officially online.
Separator vessels split raw petroleum fluids into crude oil, gas, and produced water.
Chemical treatment systems prevent wax buildup inside crude oil flow lines. Corrosion inhibitors protect petroleum pipes carrying wet crude oil across the oil field.
Water cut analyzers measure how much water is mixed with the produced crude oil.
Flow meters record petroleum production volumes from every active crude oil well.
We have an amber alert on the main pipeline junction.
I see it. Rerouting the feed to the secondary line.
Check the pressure once you're done with that last bolt. Looks good, Foreman. Holding steady.
Spare generators support petroleum equipment when crude oil operations lose external power. Flares safely burn excess petroleum gas during crude oil system upsets.
Pre-water knockout units strip excess water from field-produced petroleum liquids.
Vapor recovery systems capture petroleum vapors escaping from crude oil storage tanks.
Gravity is holding steady at 32 API.
And the sulfur content is well within the acceptable range. Sediment levels are negligible.
Crude oil is classified as light, medium, or heavy petroleum before transport.
Metering stations certify the exact crude oil volume sold into the petroleum system.
Pump stations maintain pressure so crude oil keeps flowing through the petroleum pipeline. Vapor recovery systems capture petroleum vapors escaping from crude oil storage tanks.
The flow velocity on the main line is fluctuating outside the acceptable range.
I see that. Adjusting the pressure regulators now to compensate. Leak detection systems guard the crude oil pipeline against petroleum losses. Crude oil from inland fields reaches coastal petroleum export terminals by pipeline.
The manifest says 50,000 barrels, but the gauge reading here is slightly off.
Seal 4B is intact, Supervisor. No tampering.
All right, everything seems to be in order. Let's clear it.
We need to adjust the blend ratio on the light crude to stabilize the viscosity.
Agreed. Let's increase the flow rate by... Sulfur content is lower than expected in this batch.
Yes, but the nickel levels are slightly elevated.
cleaned crude oil enters the refinery, ready for the complex process of full petroleum conversion into gasoline.
Desalters wash crude oil to remove salts that could damage petroleum refinery equipment.
The refinery takes control of the crude oil stream and begins the gasoline production cycle. Naphtha fractions from crude oil are collected as key petroleum feed for gasoline production.
Kerosene cuts separate from crude oil in the middle section of the petroleum column. Diesel range petroleum fractions condense below the lighter crude oil products. Side strippers improve the purity of each petroleum fraction separated from crude oil.
The separation is degrading. Sharpen the reflux slightly.
Confirmed. Rates are normalizing across the column.
These chromatograms are showing a clear separation at the specified cut points.
Agreed. The data confirms the yield for this fraction.
The crude oil distillation unit becomes the starting point for every later gasoline stream.
Straight-run crude oil naphtha is too weak alone and needs petroleum upgrading for gasoline.
Sulfur in crude oil fractions must be removed before clean petroleum gasoline can be sold.
Distillation transforms raw crude oil into separate petroleum building blocks for gasoline manufacturing.
The refinery now sends selected crude oil fractions into advanced petroleum conversion units.
Reduced pressure allows heavy crude oil fractions to vaporize without petroleum cracking damage.
Vacuum gas oil is recovered from crude oil residue as valuable petroleum conversion feed.
Heavier petroleum bottoms from crude oil vacuum distillation are routed to asphalt or fuel oil systems.
Vacuum gas oil becomes an important petroleum feedstock for future gasoline production.
The octane rating is dropping. Increase the reactor temperature by 5 degrees. Done. Feed quality is optimizing.
Crude oil residue still contains energy-rich petroleum molecules useful for gasoline conversion.
Heavy crude oil upgrading plans depend on refinery petroleum configuration and gasoline demand. Not all crude oil yields the same gasoline potential, so petroleum routing is constantly optimized.
Vacuum processing helps the refinery extract more gasoline value from each barrel of crude oil.
Hydrotreaters reduce nitrogen and metals in petroleum feed derived from crude oil. Clean naphtha from crude oil treatment becomes a safer petroleum feed for gasoline reforming. Kerosene and diesel petroleum streams from crude oil also pass through sulfur removal units.
Refinery hydrogen plants support the petroleum cleanup needed for modern gasoline production.
Treated petroleum streams now meet stricter environmental standards for finished gasoline quality.
The results are clear. We've met the low sulfur targets.
Perfect. Let's sign off on this batch.
The refinery cannot produce clean gasoline efficiently unless crude oil naphtha is properly hydrotreated. Purified petroleum feed now moves into the main gasoline-making conversion units.
Straight-run crude oil naphtha enters catalytic reforming to create high-octane petroleum gasoline components.
Reforming rearranges crude oil hydrocarbons into aromatic-rich petroleum molecules with stronger gasoline octane.
Hydrogen released during petroleum reforming is reused elsewhere in crude oil refining.
Reformate from crude oil, naphtha, becomes one of the most valuable gasoline blending streams.
Isomerization converts straight-chain petroleum molecules from crude oil into better gasoline blend stock. Catalysts inside reformers determine how much premium gasoline can be made from petroleum feed.
Reformer furnaces keep petroleum reactions stable while boosting gasoline octane.
Reformate, isomerate, and treated naphtha together form the core petroleum base of gasoline.
The gasoline demand forecast requires us to increase severity.
Agreed. Let's move the target to 105 and monitor the butane yield.
These upgrading units transform low-value crude oil fractions into high-value gasoline components.
The refinery now turns to cracking units to make even more gasoline from heavy petroleum streams.
Vacuum gas oil from crude oil processing enters the FCC unit for gasoline-focused petroleum conversion. FCC gasoline becomes a major contributor to total petroleum gasoline output.
Fractionators split FCC petroleum products into gasoline, light gas oil, and fuel gas streams. Hydrocrackers use hydrogen to convert heavy crude oil fractions into cleaner petroleum gasoline components.
Hydrocracking helps refineries make more low-sulfur gasoline from difficult crude oil feedstocks. Additive injection gives the final gasoline detergency, storage stability, and petroleum retail performance.
All parameters are within spec. Octane rating is strong.
Good. We can clear the batch for shipment.